Hello everybody, here we are at my washing machine whiteboard and we are going to look at the cover-up method or approach for the chain rule in a way that I can actually do it with my hands and show how you guys might do it more on your paper. I tried recording this earlier today in the live Zoom class session, but Zoom was apparently not having it and recorded just my audio and not my video. So here we are for take 2. Okay, so this is the first example from the 3.6 packet. We've got our function here, y equals 3x plus 5 squared. And we've already taken the derivative of this using the chain rule in a couple different ways on the previous video. Then we also checked it by distributing it out and just using the power rule. So here I want to show you that cover-up method again, but just by covering up by using my hand instead of like scribbling on it like I did on the computer. So you'd look at your function here and you'd say, okay, there's an inside part, a clear inside part to this function. That's the 3x plus 5 right there. So what I'm going to do is I'm going to cover up the inside using my hand. And so now our function is just hand squared. Pretend you don't know what's under there. It's just like hand is your variable now. And what's the derivative of hand squared? Well, that would be 2 hand to the first power. So that's our move here. Y prime equals 2. My hand is going to go right there to the first power. Okay, so 2 hand to the first. And then, so that's the covered up bit, and then you uncover and see what was there. So remove hand and we see that it's actually 3x plus 5. Okay, that's what needed to go in the place of hand down here in the derivative. So 3x plus 5. All right, and then the next step for our chain rule is to multiply by the derivative of whatever you uncover. So we uncover this, see that it's 3x plus 5. So we've got to multiply by the derivative of 3x plus 5, which is 3. So that is derivative of 3x plus 5. Derivative of whatever was under your hand. Okay, which can definitely be more complicated than just 3, but that's where we're starting right now. So this is how we ended up with a derivative of 6 times 3x plus 5 for our final answer there. Okay, and we checked that by distributing out this function and using the power rule, and it did check out. So that's good. There are other functions though where you wouldn't be able to do that necessarily. You wouldn't want to really distribute out. So if we make just a little change here, this is problem number 2 on the packet now. If you change that 2, the squared, to a 20th power. Okay, and then you don't want to distribute that out anymore. No, no, no. But with the chain rule, the process is very much the same. Okay, you'd cover up the inside there. And so now your function is just, get rid of that stuff. Your original function is just hand to the 20th. Okay, so you say, that's my outer function. What is the derivative of hand to the 20th? Well, it'd be 20 hand to the 19th power. So we do y prime equals 20 hand to the 19th. And then you would remove your hand, see what hand really is. It's 3x plus 5. Stick it in right there. And then multiply by the derivative of whatever was under your hand, which is, again, 3. Okay, so then we have the derivative here. Y prime is 60 times 3x plus 5 to the 19th power. And then we're done with it. So yeah, that's just a nice basic example of the chain rule using this cover up or hand method.